Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. So first kali macam biasa kena check mic apa semua dulu. So can you guys hear me clearly? Boleh dengar elok tak? Dengar elok tu nak adjust sikit. Hari ni dia sebab baru lepas hujan, so dia macam kurang sikit. Line tu macam kurang sikit sebab baru lepas hujan. Korang kat rumah hujan ke? Right, so now let us start first, and then by 8:30 I think, before I start with the binomial expansion, I'll give you the attendance. So nanti saya hantar attendance lah dekat channel macam biasa. Okay, so now let us start then. Okay, so this is the second lecture out of 3. So we are still at chapter 3, sequences and series. So basically we should be able to finish this chapter by this week. So that means next week we are going to start with new chapter 4, matrices and system of linear equation. Okay, sequences and series, the second lecture. Okay, so the learning outcome for today, you should be able to find the n term of a geometric sequence and series. So the n term, that means Tn. So you should be able to use this formula, Tn equal to Arn minus 1. And to use the sum formula, so Sn equal to A 1 minus r to the power of n over 1 minus r for r not equal to 1. Because otherwise we are going to get 0 in our numerator, and that will make everything become infinity. So that is for 3.1 sequences and series. And then after that, we are going to start with a new subtopic, which is to find the expansion of a plus b to the power of n, where n is a positive integer. So we are going to try to expand a plus b to the power of n, where n is a positive number. So perhaps, for example, a plus b to the power of 4, a plus b to the power of 5, and then a plus b to the power of 6, and so on. So those are the second one. And then write the n factorial notation. So when you want to use the formula for the expansion, we are going to get something with a factorial. So you should be able to learn how to write the n factorial notation, and then write down nr as NCR, which is binomial coefficient. So we have binomial expansions, so we are going to have something called the binomial coefficient. So this binomial coefficient is simply this NCR, which is NR. Yang ni bukan ada, dia tak ada per dia bukan macam ni. Dia memang NR, memang tergantung macam tu. Maksudnya NCR. So later I'll teach you how to use your calculator for NCR. Okay, proceed. Next. Okay, so like I told you before, we have 2 subtopics in this chapter. So we have learned about arithmetic previously, so done. So today we are going to learn about the geometric sequences and series, and then we are going to start with some example on binomial expansion, which we are focusing on the positive integer. So this coming Wednesday, we are going to do the binomial expansion for rational numbers. Okay, now geometric sequence. So last time we learned about arithmetic, but this time this is geometric sequence. So geometric sequence is actually the sequence of the form AR square, AR cube, AR to the power of 4, where A is the first term, AR is the second term, AR squared, that is the third term, AR cubed, that is the fourth term, AR to the power of 4, that is the fifth term, and so on. Okay, so first term, second term, third term, fourth term, fifth term. Okay, so what is A? A, as usual, A is the first term, and R is the common ratio. So ratio maksudnya kena bahagilah, common ratio. So how to find the value of R? We are going to take Tn, we are going to divide with Tn minus 1. So you are going to get the value of R, but there's some special thing where the R cannot be equal to 0 and R cannot be equal to 1 as well, because basically if we have 0, that means you are not going to get any geometric sequence. If you have 1, the same thing as well, that is not a geometric sequence sebab kita akan repeat benda yang sama saja. Okay, so now how are we going to get the n term? So n term, that means Tn. So the formula for Tn is ARn to the power of negative 1. So this is geometric sequence. So for arithmetic, there are two things. You need to calculate your first term and common difference. But for geometric sequence, again two things, but first term and common ratio. So before this, we have common difference. Now we have common ratio. Okay, next, let us go to some of the example. Given that the geometric sequence 8, 16, 32, 64, and so on. So firstly, we need to find the general term. Okay, so if you read this question, the general term stand for T. General, that means we are looking for the n. So we want to get what is the n. And then the second one, you have to calculate what is the 9. So basically, of course, you're going to do the first one first, find out what is the general term, and then we are going to substitute n with 9 in order to get the 9. Okay, so now geometric sequence, like I told you before, geometric sequence, there are two things that you will need to find out. Firstly, you need to know what is your first term. The second one, you need to know what is your common ratio. So how to get the first term? So basically, this is T1, T2, T3, T4. So the first term is automatically 8. Okay, so how are we going to get the common ratio? So R is equal to Tn over Tn minus 1. Since I know this is a geometric sequence, I can choose any of them. So I choose T2 over T1. So T2 over T1. So 16 is T2, 8 is T1, so T2 over T1. That will give me a common ratio of 2. So of course you can try T3 over T2 as well, or T4 over T3. That will give you the same answer, which is 2. Okay, so now you already have your first term, you have your common ratio. Of course, you can easily substitute into the formula of Tn. Okay, so let us go to the formula of Tn. So Tn is AR to the power of n minus 1. So substitute A is 8, R is 2. So we got 8 multiply with 2 to the power of n minus 1. Okay, so of course we should try to write them down in the simplest form. So let us check whether can I change everything into the same base or not. Okay, so 8, what do we know about 8? 8 actually can be changed into base 2, where I can have 2 cubed as 8. So 8 can be changed to 2 cubed. So I have 2 cubed multiply with 2 to the power of n minus 1. And this is a multiplication, right? So that means I can simply add the power. So it's like having a to the power of n, a to the power of m. So this is a, n plus m. So we are going to add the index together. So it will become 2 to the power of 3 plus with n minus 1. So 3 minus 1, that is 2. So we got Tn equal to 2 to the power of n plus 2. So this is Tn. So simplify them a little bit. If you can, simplify them. Okay, so now I already have what is my Tn. So now let us calculate what is T9. Okay, T9, that means you should substitute n with 9. So this is 2 to the power of 9 plus 2. So substitute the n with 9. So 9 plus 2 is 11. So we have 2 to the power of 11. And then we can use our calculator, find out what is the value for 2 to the power of 11. So if you try to use your calculator for this, it's supposed to become 2048. Okay, so that is basically how we are going to obtain the general term and the specific term. Okay, so this is a simple example. Let us go to the next one. Okay, the n term of a sequence is Tn equal to 2 over 3 n minus 1. Show that it is a geometric progression. So geometric progression, it is similar to geometric sequence. So you can write down GP or GS, whatever. Okay, geometric progression. Okay, how are we going to show that we have a geometric progression? So do remember, you have two things for your geometric progression. So the first one, you will have your first term. The second one, you will have your common ratio. So of course lah, takkan nak guna first term kan. First term, arithmetic pun ada first term. Apa-apa sequence pun ada first term. So of course, we are going to use the common ratio because that is the most specific thing for geometric progression. So again, I repeat, geometric progression, you have two things, the first term as well as the common ratio. First term, biasanya untuk setiap sequence memang ada first term. Bukan biasanya lah, memang semua sequence ada first term. So of course, you cannot use based on your first term. So you got to use your common ratio. So proof from your common ratio. The word common, you guys know what does the word common mean? Tahu tak common tu apa? Common ratio. What does it mean? Common ratio. What does it mean by having a common ratio? Anybody know? What does it mean by common ratio? Nisbah sepunya. Bolehlah. Bukan bolehlah apa maksudnya. Betul lah. Nisbah sepunya. The same ratio. Abel. The same ratio. That means throughout this sequence, you are going to get the same ratio ataupun nisbah yang sama saja. Okay. Ratio of each term. So T1, T2 over T1, T3 over T2. They will get the same answer, right? Nilai yang sama saja. So kalau nilai yang sama, that means for the value of R, you are supposed to get some constant. Maksudnya mungkin kita dapat nilai dia macam 1 ke, 2 ke, 8 ke, 10 ke. So we are not supposed to get something like 2 to the power of n. This one, it will change depending on the value of n. So the word common itself, meaning that we are supposed to get some constant, which is the value doesn't change. It won't change. So kalau kata kita contoh ada 2 kuasa 1 per n. So nanti kalau n ni berubah, nilai ni pun akan berubah juga. So this one is not a common ratio. Boleh faham ke setakat tu? You are supposed to get some constant because this is a common ratio. Okay, so now how are we going to get R or the common ratio? So basically we are going to use the general formula for them where R is Tn over Tn minus 1. So what is your Tn? Tn is 2 over 3n minus 1. So what happened now is that we are going to replace this value of n over here. Okay, so Tn, that means you are just going to copy down everything. For Tn minus 1, you are going to replace the n with n minus 1. So let's see how. Okay, so this one over here, 2 over 3 n minus 1 because this is Tn. for Tn minus 1, you are going to replace the n with n minus 1. So it become n minus 1 minus 1. Okay, so we got 2 over 3 n minus 1. And then below here, we have 2 over 3 n minus 1 minus 1. So basically, we do have the same base. It's like having a m over a n. So what I can do is that I can use the rules of indices for them. So this is a to the power of m minus n. So you're going to simplify them a little bit. Okay, so what happened to them? So this one will become n minus 1 minus n minus 1 minus 1. So n minus n cancel out, negative 1 plus 1 cancel out. So you will be left with 2 over 3. This one will become positive 1. So 2 over 3 to the power of 1, which is simply 2 over 3. And this is actually a constant because we don't see anything with n. So it won't change throughout the sequence. So pilihlah apa-apa nilai t sekalipun, we are going to get a common ratio, which is the same ratio from the start to the end. Okay, so since we have a constant as the common ratio, hence this is a geometric progression. Okay, so this is basically how you want to prove that you have a geometric progression. So ini untuk common ratio. Kalau contohlah untuk arithmetic, for example, for arithmetic, you got to use the d, where d is dn minus dn minus 1. So yang ini pun kena dapat constant jugalah sepatutnya. If you want to prove you have an arithmetic sequence, then you should start from the common difference, which is dn minus 1. Prove that you are definitely going to get some constant. So that is how you're going to show you have an arithmetic sequence. For geometric sequence, we are going to prove from the common ratio. Okay, so now I have already proven that this is a geometric progression. So now let us proceed to B. Okay, so B, it said find the value of n where Tn is 256 over 6561. Okay, so now let us use the formula then. Okay, so Tn is 256 over 6561. Okay, so Tn, oops, I forgot. Tn, they already give you the formula. This is 2 over 3 to the power of n minus 1, which is this one over here. So yang ni ignore lah. Okay, so 2 over 3 n minus 1 equal to 256 over 6561. Okay, and then what should we do? Right, so this is simply chapter 2. So you can choose either to compare your base and your index, or you can apply log on both sides. So I do find that if let's say I'm quite confused, then I normally love to use log. Biasanya kalau saya confused, saya nak tukar nombor apa, saya akan pakai log lah. But for this one, the number is quite easy. So I simply use the base and index. I simply compare the base and index. Kalau rasa macam nanti nak jawab, rasa macam tak faham, so better to use log on both sides. So I'll show you how to use log on both sides. So basically, if you use log on both sides, it will become n minus 1 log 2 over 3 equal to log 256 over 6561. And then n minus 1, this is log 256 over 6561 divided by log 2 over 3. So from here, do make sure to calculate them one by one. So mesti kena kira log ni nilai dia berapa dulu, and then calculate this value over here, then you divide. So jangan potong log dengan log tu tak boleh potong. Nombor dengan nombor tu pun tak boleh bahagi terus. Dia mesti kena apply log dulu. So log 256 over 6561, and then you divide them by log 2 over 3. And then if I'm not mistaken, n minus 1 should be equal to 8. Never mind, let us try. So 256, 6561, log answer divided by log 2 over 3. Yeah, 8. Okay, therefore n is equal to 9. Okay, so you can apply log on both sides just like what I did over here, or we can actually use compare the base and the index. So ini satulah macam mana nak guna compare base and index. So siapa yang nak salin ni dulu. I want to show you how you can use compare base and index. Okay. Right, so 256 is actually 2 to the power of 8. And then 6561 is actually 3 to the power of 8. So I can actually simplify this to become 2 over 3 to the power of 8. So now I have the same base. I just need to compare the index. So by comparing the index, you are going to get n minus 1 equal to 8. N must be equal to 9. Apa dia? Random kalau kita tekan calculator tu dapat decimal nak buat macam mana? That is totally fine because sometimes we need to have the decimal point. Tak ada masalah pun kalau dapat decimal. Cumanya untuk soalan ni sepatutnya dia bukan decimal lah. Untuk soalan ni dia memang solid number. Tapi kalau untuk calculation yang lain tak semestinya akan dapat number lah. Dia mungkin akan dapat decimal. Kalau decimal kita akan bundarkan nanti. Hujung-hujung nanti baru bundar lah. Bukan sekarang. Hujung nanti baru bundar. Dekat sini sepatutnya mesti kena nombor yang solid It's fine. That means you must take the number, the whole number. So make sure you use log and then put a bracket and then 256. You divide them by 6561. And then divide with log to make sure to put some bracket to divide by 3. So you are supposed to get some value 8, exactly 8. Dia memang dah tak ada benda lain lah. Tapi kalau kata dapat decimal tak apa, go on je lah. Andai katalah kan awak tak dapat nombor yang betul, awak dapat decimal je, tak apa, go on. Nanti final answer kita akan bundarkan. So n sama dengan berapa. Okay, done with example 2. Next. Okay, so now the sum of geometric sequence. So basically for geometry, you have two formula for sum of n term, the first n term. So you can use Sn equal to a1 minus r to the power of n over 1 minus r, or a r n minus 1 over r minus 1. So the difference between this formula is that the first formula we are going to use when the value of r is actually less than 1. So the second formula is mostly used when the value of r is greater than 1. So one of them is less than 1, another one is greater than 1. But actually you can choose to use either of them sebab nanti kita akan main dengan simbol, dia akan dapat sama balik sebenarnya. So you can use either one, it will be the same answer. Biasanya kita guna pakai yang ini sebab nak memudahkan pengiraan, supaya nanti tak adalah atas dapat negatif, bawah dapat negatif, lepas tu pening tak tahu nak buat apa. Okay, so this is the sum of the first n term, and then we have something quite new because you haven't seen this before in arithmetic. We actually have the sum to infinity for a geometric sequence where the formula is s infinity equal to a over 1 minus r, but there is a restriction for the value of our common ratio where r need to be, the modulus of r need to be less than 1. So that means the common ratio will be in between -1 and 1. If you want to use the sum to infinity, you must make sure that the value of r is in between -1 and 1. Otherwise, it won't work. It doesn't work. Dia tak dapat lah, dapat nilai, awak ada lah kira something, but that value does not represent the sum to infinity. That is just a value that you calculate, but it's not a sum to infinity. Okay, next. Right, so find the first 5 term, the sum of the first 5 term of geometric progression. So GP stand for geometric progression, which the value of the first term, a is equal to 27, and the common ratio is 2 over 3. Okay, so now we are going to try to substitute into the formula. What is the formula for Sn? Okay, so A is 27, R is 2 over 3, and then since this is S5, that means the value of N is actually equal to 5. Right, so use the formula for them. We are going to substitute n with 5. So a 1 minus r to the power of 5 over 1 minus r. Okay, so now substitute the value of a, substitute the value of r in. So we are going to get 27, 1 minus 2 over 3 to the power of 5 over 1 minus 2 over 3. Okay, so for those of you who have this kind of calculator, the same one like mine, which is the black version, you might need to calculate one by one, otherwise it will be a little bit confusing. So do calculate 1 minus and then put some bracket, 2 divided by 3, and then make sure to use the power of 5. So you should calculate 1 minus 2 over 3 bracket to the power of 5 first. So calculate this one. And then you times them with 27. Okay, this one. And then we are going to times with 27. And then you are going to divide with, okay, so divide with, you are going to write down 1 minus 2 over 3. Okay, so 1 minus 2 over 3. Okay, so you are going to get your value, which is 70.777. Normally for me, I use some fraction for them because I want to get some exact value. So I simply change it to become 211 over 3. If you are using the grey version or the white version of the calculator, you can simply write them down, simply masuk je semua sekali. Serentak pun boleh, tak ada masalah. Kalau yang grey atau putih tu dia tak ada masalah, dia boleh handle fraction yang kompleks. Tapi untuk yang warna hitam tu dia particular sikit, so sebab tu kita kena kira, better kira satu persatu lah. Okay, next. Calculate the sum to infinity of the series. So we got 2 plus 1 over 2 plus 1 over 8 plus 3 over 2 plus dot dot dot. Okay, so sum to infinity. What is the formula for sum to infinity? The formula is a over 1 minus r. Okay, so we need to know what is our first term and what is the common ratio. Okay, so 2 plus 1 over 2 plus 1 over 8 plus 1 over 32. So of course the first one, this is the first term, or that is actually our a. How to get the common ratio? So common ratio, you can either choose the second one, you divide with the first one, or you can choose the third one, you divide with the second one, or you can choose the fourth term, you divide with the third term. So choose either one so that you can have the common ratio. Okay, so the first term is 2. My common ratio, I simply use T2. So I use T2 over T1. So T2 is half. I divide them by 2. So half over 2. That answer is 1 over 4. And then we are going to substitute into the formula of S infinity. So A is 2 over 1 minus 1 over 4. So 2 over 3 over 4. So S infinity is simply equal to 8 over 3. Okay, so that is basically how we are going to calculate the sum to infinity. Okay, done. Next. Okay, so now express each of these number as a quotient. So if you do remember back in chapter 1, the first chapter, the first lecture, we do learn something called the rational and irrational number, right? So we do know for a rational number, let me represent them as a Q. For a rational number, you can represent them either in a fraction or in decimal. Fraction, that means you are supposed to write them down in the form of a over b, where both a and b are integer. Decimal, it can either be repeating or terminating. Okay, so terminating, it should be quite easy for you to change it to fraction. So now we are going to see this repeating decimal. we are going to change them into fraction with a over b, so that we can easily see what is the value of a and what is the value of b. So that is our aim actually. We want to write down the rational number as a fraction. Okay, so now what is 1.6 with a bar on top of 6? So that is actually 1.6666666 and so on. Okay, as you can see, this is something that is repeating. We are going to keep repeating the 6 infinitely. So kita akan sentiasa repeat infinitely. So of course, in order to calculate this, we are going to use S infinity, the sum to infinity. Okay, so now let me separate them first into two. Firstly, that is the number that is not repeating, and then the number that is repeating. So let me separate them into two first. Okay, so 1.666, the number that is repeating is that 666. So I'm going to separate them into two. So 1 that is not repeating, and then we have the repeating number over here, 0.666 dot dot dot. So I'm going to use S infinity for this one. So that means I should find out what is the value of A and what is the value of R. Okay, so S infinity is A over 1 minus R. Okay, so I want to know what is the value of this A over here and what is the value of R, the common ratio. Okay, so how are we going to get the first term and the common ratio? So basically from 0.666 and so on, I'm going to do one sequence for them, which is I'm going to separate the number a little bit so that we can see what are the sequence. Okay, so 0.666, I'm going to separate them based on the decimal, the repeating number. Okay, so I will have 0.6, so that is the first one, and then the second one I'm going to put 0 over here, so it will become 0.06. For the third one, it's going to be 0.006 plus so on. Okay, so now the thing at the back over here, I'm going to use S infinity for them. So I'm going to calculate what is the value of A and what is the value of R. Okay, A is the first term. So this is my first term, second term, third term, and so on. Okay, so A is 0.6. What about the value of the common ratio? So the common ratio is 0.06 over 0.6, which is 1 over 10. Okay, so the sequence at the back, I'm going to use S infinity for them. So I'm going to separate them into a few numbers so that I can easily see what is the common ratio. So take the first term, find out the common ratio, and then we are going to use the formula for S infinity for the sequence at the back. Okay, so now 1.6, that is exactly equal to 1. So ini adalah number yang tak repeat tu, 1. And then this one at the back is the one that I use as infinity. Okay, so A over 1 minus R. Okay, so you're going to substitute. A is 0.6. The value for the common ratio is 1 over 10. So 1.6 with a bar is actually 5 over 3. Yang ni nanti kira lah guna calculator. Pastikan kita nak tukar dia dalam bentuk fraction as a quotient. Again, what do we need to do? Firstly, write down the number first. See which number that is repeating and the number that is not repeating. Make sure you separate them. This is the repeating part. This is the non-repeating part. Okay, so the repeating part, we are going to write down some sequence for them. The non-repeating part, just leave them as it is. For the repeating part, we must separate them by the repeating number. And then we are going to calculate the sequence for them. Calculate what is the first term, calculate what is the common ratio, and then we are going to use S infinity. Okay, so let us try to do another example together. Okay, so for example, over here we have 5.459 with a bar. Okay, so what does it mean? A bar on top of 59. A bar on top of 59, that means the 59 will keep on repeating. So we are going to get something like 5.4, 59, 59, 59, and so on. Okay, so I'll give you around 3 minutes. Try to see whether can you get the quotient or not. So I'll give you around 3 minutes. What is the next step over here? Make sure you separate the number that is not repeating, the number that is repeating, make a sequence for the repeating number, calculate the S infinity, and you are going to get the quotient. Okay, so I'll give you 3 minutes starting from now up until 8:39. And then we are going to check our answer together. Kalau ikut sebenarnya panjang lagi, tapi tak apalah. Saya bagi masa juga. Cuba dulu. Oh, saya nak bagi attendance pula. Okay, sekejap. Okay, so it's already 8:39. So let us check. Let us check this together. Okay, so where is the repeating number? So the repeating number is at the back over here, which is 59, 59, and 59. Okay, so I'm going to separate them into two numbers that is not repeating and numbers that are repeating. Okay, so it will become 5.4 plus 0.0595959. So be extra careful. This one over here, this is the non-repeating number, so 5.4. So that means this one over here is definitely 0 sebab kita dah ambil 4 kat depan kan. So belakang tu akan tinggal 0.059595959. Okay, so now the repeating number is the number at the back. So this is a sequence. So we are going to calculate the S infinity for them. So let us calculate what is the value of A and what is the value of R. So firstly, you might want to separate the number first so that we can easily see what is the value for the first term, the second term, third term, and so on. Okay, so where is the repeating number? 0.59, 59, 59. Okay, so when you write down the term, okay, the first one will be 0.059. I think that will be quite easy for you to see. But the second one, be extra careful. Over here, we have three places in front. So that is the reason why you are having 0.00059. And then the third term, you are supposed to get 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. So over here, 5 places. And then 59. Okay, so now based on this sequence, the value for the first term is 0.059. So this is the first term, second term, third term. Okay, so the value of A is 0.059. The value for R is 1 over 100. So substitute into the formula for S infinity. So 5.459 with a bar is 5.4 plus A over 1 minus R. So when you try to substitute the value of A and the value of R, you are supposed to get the fraction, which is 5.4 plus 59 over 990, and that will give you 1081 over 198. Did everyone get the same answer? Did you get the answer? Ke ada bahagian mana-mana yang stuck? Ada bahagian mana-mana yang nak kena repeat ke? Okay. Are you guys doing good? Okay ke ni? Dapat. Okay. Right. Okay, kalau dah dapat, done. Okay, so kalau rasa macam tak boleh dapat lagi, sekejap lagi bagi tahulah. Okay, done. Now let us proceed with 3.2, binomial expansion. Okay, so for binomial expansion, we are going to do a few examples for binomial expansion actually. And then we will finish binomial expansion, the first formula for the binomial expansion, and continue this coming Wednesday. Okay, so binomial expansion, how are we going to expand? Okay, so this is a simple example. If let's say you have a plus b to the power of 1, so that is actually a plus b. If we have a plus b square, so this is the formula, right? So a cube plus 2ab plus b squared. If you have a plus b cubed, so some of you might do something like a plus b multiply with a plus b square, where you expand the thing at the back. So this is a plus b multiply with a square plus 2ab plus b square, and then you expand them again, and then you are going to get a cube plus 3a square b plus 3ab square plus b cube. But what if we have a plus b to the power of n? That means the n is not 1, 2, 3. It can be a very big number. For example, a plus b to the power of 20. Or perhaps a plus b to the power of 100. Are you guys going to keep on expand them one by one like this? So of course, the answer is definitely no. It's a waste of time. So that is the reason why we have to learn binomial expansion, so that we can expand anything much more easier. So it will be quite easily for us to expand everything. Okay, so now the two things that you need to consider when you want to expand a plus b to the power of n. Firstly, you need to know how many terms are they in the expansion, and then how to find each coefficient of the expansion. Okay, so for example, a plus b to the power of n, to the power of 1, sorry, a plus b to the power of 1, how many terms is this? So this is 2 terms. A plus B square, how many terms? 1, 2, 3. So this is 3 terms. A plus B to the power of 3 is 1, 2, 3, 4. So that is 4 terms. Oops. Okay, so now I want to ask something. This is A plus B to the power of n. How many terms are you going to get? How many terms? Ada berapa terms for A plus B to the power of n? If we have A plus B to the power of n, to the power of 1, it will be 2 terms. A plus B squared, so it will be 3 terms. A plus B cubed, so that is 4 terms. What if we have A plus B to the power of n? How many terms? Yes, Faiza, you're the first one and you got them right. It's supposed to be n plus 1. We should always add 1 to the value of n. That will be the number of terms. No, Adam, no. It's not n terms, but n plus 1 terms. It should be plus 1 to the n. If you see over here, this is 1. But how many terms? 2. This is 2. How many terms? 3. This is 3. How many terms? 4. So that means the number of terms is always the index plus 1. Sentiasa tambah 1 dekat power tu. So that is the number of terms. Okay, the second one, when you want to expand, there are one more thing that you should consider. How are you going to find each coefficient? So how are we going to get the value for 2 over here, or how are we going to get the value of 3 and 3? So it might seem a little bit not too obvious. How are we going to get each coefficient? So that is the reason why you have to learn something called the Pascal triangle. So this is basically the most ancient aku boleh lah cakap itu, the most ancient thing, how to calculate the Pascal triangle. So Pascal triangle, like the name itself, is supposed to be a triangle. It's supposed to look like a triangle over here. Nampak ke? Penat semalam saya pergi beli Lego, satu makan nak ajar kat awak. Something like this. Okay, so now let me teach you how are you going to do this triangle. Okay, so firstly, if let's say the first one at the top, so it should be 1. So saya tulis 1. Okay, so now kalau awak buat Lego, kita nak buat triangle tau. So of course yang bawah daripada 1, atasnya ada 1 je, bawah ni mesti kena ada 2 kotak. So 2 tu pun dia ada 1 kiri, 1 kanan. So untuk Pascal triangle, the left hand side and right hand side need to be 1. So yang ni for the left and right hand side, they need to be 1. Nampak ke? Buat je tu. Okay, so now the third layer. Okay, this one, the first layer, second layer, third layer, of course 3 Lego then. Okay, so the third layer, the one on the left must be 1, the one on the right must be 1 as well. So you can write down 1 and 1. Okay, so what about the middle one? So sekarang ni masalah dia tengah-tengah tu lah kan. Okay, so right in the middle, what you need to do is you need to add the number on top of them. So yang tengah-tengah ni merah ni kan. So atas daripada warna merah tu warna apa? So atas daripada merah tu adalah yang yellow tu. So both number are 1 and 1. So you should add them together so it will become 2. Ding. Kalau tak adik, dia ambil Lego adik. Sabar ya. Tu. Okay, so now the fourth layer. The fourth layer, the same thing actually, the left hand side and right hand side need to be equal to 1. So make sure to write down 1 on left and right hand side. Nampak ke? 1. Okay, and then for this blue part, you should add the two blocks together. So dia ada 1, 2, so this is 3, 2, 1, that is also 3. So that is how you get 1, 3, 3, 1. Okay, the next one. Payahlah pula nak buka. Okay. I guess this is the last one. Tak larat nak pegang tangan kiri. Okay, so the most left and the most right hand side need to be 1. 1 and 1. And then right in the middle you should add the box or the blocks yang atas tu. Okay, contohnya yang sebelah sini atas dia ada 1 dengan 3. So this one will be 4. 3 plus 3, so 6. 3 plus 1, so that is 4. So that is how you end up with 1, 4, 6, 4, 1. Okay. Dah, tak larat dah nak buat yang last tu. Okay, as you can see, we keep on, when we add the blocks, we keep on write them down in a triangle kan. Dia sentiasa dalam bentuk triangle. So that is why we're gonna call them as the Pascal triangle. Sebab itulah angka Pascal tu dipanggil dia Pascal triangle. Okay, so just in case you couldn't see what happened over there, the first and the last number is always 1, but the one at the middle you should add whatever number or whatever box that is on top of them. So for example over here 1 plus 1, so that is how you get 2. How to get 3 over here, this is 1 plus 2 and then 2 plus 1 and then 1 plus 3, 3 plus 3, 3 plus 1. And then this one over here, oops. This one over here is 1, 4, 4, 6, 6, 4, 4, 1. So that is how you get 1, 5, 10, 10, 5, 1. So that is the Pascal triangle. Later on, I'll show you the magic of using Pascal. It will be very easy for us to expand. Okay, so now let us see some example. Sebab nanti kalau tak tengok example tak tahu nak kira kan. Okay, so I know the coefficient now. How are we going to get the term? Okay, so for example, if let's say we want to expand a plus b to the power of 5. Okay, so firstly check the power first. The power is 5, so that means how many terms are we going to get? Just like what you said over there, it's supposed to be n plus 1. So the value of n is 5, so that means I should have 6 terms. Oops, 6 terms. Okay, so in order to have 6 term, I should leave some space to them. Okay, so for each of the term, I will have 3 different brackets. Okay, later on I'll show you why we have 3. Okay, but now just simply write down 3 brackets for each of the term. Okay, so the first term I have 3 brackets. So bracket 1, 2, 3. So this is for my first term. Plus with my second term, another 3 bracket, plus with the third term, plus with the fourth term, plus with the fifth term, plus with the sixth term. So make sure you leave some space for the 6 terms. So bracket, 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 bracket. So do all this bracket. And then once you are done, please write down done. And then we are going to continue. So ini kena buat sama-sama. Tak buat sama-sama nanti kan dia confuse seorang-seorang. Once you are done with the bracket, let me know. Just prepare some bracket first. We have 6 term, and for each term, make sure to have 3 different bracket. Done. Okay, ada seorang dah done. Okay lah. Okay, so now we are saying that we should have 6 term. So that means based on your Pascal triangle, take the value for the 6 layer. So 6 layer. Sekejap, atau di Pascal. 6 layer. Oops. Okay, so this is the first layer. First, second, third, fourth, fifth, sixth. So this is third, fourth, fifth, sixth. So now we are going to copy down the value 1, 5, 10, 10, 5, 1. Okay, so copy down this value first. 1, 5, 10, 10, 5, 1. Okay, so based on the Pascal triangle, the 6 layer, 1, 5, 10, 10, 5, 1. Okay, so what are we going to do next? We are going to take each coefficient to go in the term. So the first bracket is for the coefficient. The first bracket is for the coefficient. Okay, so we are going to simply copy down the coefficient in. Okay, ready? Go. 1, 5, 10, 10, 5, 1. Okay. One by one, make sure you write down the coefficient in the correct order, okay? In the correct order. 1, 5, 10, 10, 5, 1. Okay, so once you are done with the term, let us check this term. So we have A plus B. So A plus B. So I'm going to separate them into two. A plus B. So this is the first value. This is the second value. Okay, so now the second bracket will be for the first value. So in this case, I simply gonna copy down A, 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 A. So simply copy down the A first. A, 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 A. One by one. The second bracket for the A. A, 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 A. Make sure you have write down 6A. Okay, so now we want to write down the power for each A. So we will start with the highest power that is possible. Okay, so we have A plus B to the power of 5. So the highest power that we can get is 5. So you are going to write down from the highest power, which is 5. So keep on writing down the power 5. And then you deduct 1 to them, 4. And then 3, 2, 1, 0. Always make sure you should start with the lowest power, which is n, and then you should finish at 0. Mesti habis dekat 0 punya. If not, then there is something wrong with your term. Dia mesti start dengan highest power and the last one need to be 0. Okay, so again I repeat, we start with the highest power, which is 5. And then you keep on delete 1 to them. So subtract 1, 4, 3, 2, 1, 0. And then we are going to write down B for the third bracket. So the third bracket stands for the B. Okay, so the third one stand for B. We are going to substitute B, 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 B. Okay, so once you have write down the value of B, the B, once you have down the B, now we want to write down the power for the B or the exponent of the B. Okay, so for the A, we start with the highest value, right? So for B, it should be the opposite one. So kalau untuk A, kita start dengan the highest one. That means for B, we start with the lowest one, which is 0. So for B, you should start from 0. And then you keep adding 1. So it will become 0, 1, 2, 3, 4, 5. So when you stop, you should be at the highest power, which is 5. When you start, you should start from the lowest power, which is 0. So 0, 1, 2, 3, 4, 5. Okay, so what happened next? Next, of course, we just need to simplify them. What is the value for each of them? Okay, so now, the value for them. Okay, the value for the first one, right? So 1 is stay as 1, and then we have a to the power of 5, b to the power of 0 is 1, right? So this is 1, this is 1, so we are only left with a to the power of 5. And then this one over here is 5, a to the power of 4, b to the power of 1. So 5, a to the power of 4, b. And then 10, a cubed, b squared, 10, a cubed, b squared. Then a square b cube, then a square b cube, 5ab to the power of 4, and then over here we have 1, a to the power of 0 is 1, multiply with b to the power of 5, so it will simply become b to the power of 5. So that is our expansion. Tada! So tak payahlah kita macam nak buat macam ni. Tak perlulah macam nak buat a plus b square and then darab lagi dengan a plus b square and then darab lagi dengan a plus b. Lepas tu yang ni pula jadi a square plus 2ab plus b square. And then you have another one, a square plus 2ab plus b square. And then another one, a plus b. And keep on trying to expand everything until until habis kertas tapi tak dapat jawapan. So macam ni lah kita nak guna binomial expansion. See, it will be much more easier like if we use binomial expansion compared to expanding them one by one. Sebab tu lah kita tak expand macam ni. Kita guna formula. So, kita nak mudah. Okay, so now let me go to the next example. I know that this one we actually use the formula, but I want to try to use Pascal triangle for them. Okay, so now expand 1 minus 2x to the power of 4. So I want to show what's the difference between using Pascal triangle and using the binomial formula later on. Okay, so now let us try to use the Pascal triangle first. Okay, by using binomial expansion, expand 1 minus 2x to the power of 4. So firstly, check the power. So we have n equal to 4. So n equal to 4, that means how many terms? Okay, so as usual, the answer is n plus 1. So n equal to 4, that means you will have 5 terms. So make sure to have 5. 5 times 3 bracket. So 5 terms, each term got 3 bracket. So 1, 2, 3, 4, 5. Okay, and then of course, I'll give you around 3 minutes for you to try to fill in the blank and to simplify them a little bit. Okay, so until 9:07 PM. Okay, so do try them. Cuba dulu. So in the meantime, it's my sister's birthday, so I should wish her first. Nanti dia maju. Okay, so do it slowly, one by one. Go to the Pascal triangle, find out the fifth layer because you need 5 terms. So go to the fifth layer, find out the coefficient on the fifth layer. Substitute the coefficient first, and then all the A's, all the B's, the power for the A, the power for the B. Simplify a little bit. Okay, 1 more minute to go. Let's see sampai mana yang boleh buat. Oh, tu lebih dari pukul 9 lah. Lama sikit. Saya buat yang ni lama sikit. Nak buat laju boleh tapi sebab saya rasa tak apalah, kita go slow sikit sebab untuk chapter 3 dia punya main dia atau main lah, sebab arithmetic and geometry I think you have learned during your high school. Ini adalah something yang little bit quite new, I think for some of you quite new, so I think I need to put more emphasis on binomial expansion. That's why we are going to go quite slow for binomial expansion. Okay, so now it's already 9:07. So let us try to proceed and let's see whether do you get the same one with me or not. Okay, so now we are going to go to the fifth layer of the Pascal triangle where we have the number 1, 4, 6, 4, 1. So the first bracket will be for the coefficient. So 1, 4, 6, 4, 1. Okay, so that is the coefficient. And now for the second bracket, that stands for A. So imagine if we have A plus B over here. So that means the value of A should be 1. The value of B will be negative 2x. Okay, so 1. The value for A is 1. So I'm going to keep writing down 1, 1, 1, 1, 1. And then now the highest power. So we have n equal to 4. We are going to start with the highest power, which is 4. So 4, 3, 2, 1, 0. So do keep in mind that you should start with the highest power and then keep on subtracting 1 until you get 0. Dia tak boleh negatif lah. Paling-paling sampai kosong je. Okay, and then substitute B. So B is negative 2x. So negative 2x, negative 2x, negative 2x, negative 2x, negative 2x. And then we are going to write down the power. So for the B, we should start with the lowest power, which is 0. And then keep on adding 1 until we reach the highest power, which is 4. So 0, 1, 2, 3, and 4. Okay, so now of course we should try to simplify them a little bit. Okay, so now let us go to each of the term. Okay, 1 will stay as 1. So 1. 1 to the power of 4 is actually 1. 1 to the power of anything is 1. So yang ni jadi 1 juga. 1, 1. So we have negative 2x to the power of 0. Anything to the power of 0 is actually 1. So this one is 1. This is 1. That is also 1. So 1 times 1 times 1. Everything will become 1. And then for the second term, 1 cube, this is actually 1. 1 square, that is also 1. 1 to the power of 1 is also 1. 1 to the power of 0 is also 1. So let me simplify them a little bit. So what do I have is 1 plus 4 multiply with negative 2x plus with 6 multiply with negative 2x square plus 4 negative 2x cube plus negative 2x to the power of 4. Okay, so up until here, we need to expand them, but be extra careful. Over here, you have a multiplication inside of the square. Therefore, you should apply the square one by one. So this one should be negative 2 square x square. This one, negative 2x cube. So it will become negative 2 cube x cube. This one negative 2x to the power of 4. So this is negative 2 to the power of 4, x to the power of 4. So I do find it much more easier if I separate the x and the numbers like this. If you want to over here, it will become negative 2 multiply with x. And then the number times with the number. So times everything together, you are going to get 1 minus 8x plus 24x squared minus 32x cubed plus 16x to the power of 4. So that is by using the Pascal triangle. Okay, next, we are going to expand using the binomial formula. Okay, binomial expansion formula where we have a plus b to the power of n. So we got something with n0, n1, n2, nr, and n. Okay, so what is this n0, n1, n2, nr, and nn? So this is actually called the binomial coefficient. So later on, we're going to see the formula for the binomial coefficient. And then you have the A. It is almost similar to what we have earlier, except that now we are using the general term. So kita start dengan the highest power, which is n, and then n minus 1 up until 0. And then you have B, you start with the lowest power, which is 0, and keep on adding the power to the P up until you reach B to the power of n. Okay, our focus over here is this one, the one that I put a box. This is actually the TR plus 1, which is the R plus 1 term. So if let's say you have A plus B to the power of 20, and I don't really want to expand everything, but I want to find some specific term, then I'm going to use this formula, the TR plus 1, to find a specific term. Contohnya saya nak cari coefficient untuk A to the power of 13, B to the power of 7. So I want to get the coefficient of this one. Therefore, I'm going to use TR plus 1. So yang ni besok lah. Kita masuk yang ni besok lah. Hari Rabu. Okay, next. Right. So now, binomial coefficient, the NR, that is actually NCR. So the formula for them is n factorial over n minus r factorial, where the n factorial is simply n multiplied with n minus 1, n minus 2 up until n. So for example, if let's say you have 4 factorial, that is 4 times 3 times 2 times 1. So sentiasa tolak 1, lepas tu darab lah. If let's say you have 7 factorial, then 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then if you want to use a specific term, or if you want to calculate the specific term, then you are going to use the formula for TR plus 1 equal to NCR, A to the power of n minus r, B to the power of r. Okay, so that is basically what do we have in the binomial expansion formula. The binomial coefficient, factorial, and then the specific term. Okay, so now, if let's say you want to expand this example again by using the formula, what will happen this time? Okay, so similar thing. So yang ni saya bagi laju sikit sebab tadi kita dah kira. Similar thing with what we have earlier, we simply need to have 5 term. So do make sure you have 5 term. But for the first bracket, we are going to write down the binomial coefficient. Okay, so you take the highest one, which is 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. So you will stop whenever you reach the same value at the top. So you're going to start with the lowest value, 4, 0, and then you're going to stop when you have 4, 4. And then you're simply going to write down the A. And then A will start with the highest power, which is 4, 3, 2, 1, 0. And then the B, negative 2x. The B will start with the lowest power, 0, 1, 2, 3, 4. And then of course you're going to use your calculator. So yang ni lah nak kena ajar. So 4, 0. This one simply means 4C0. So you should use your calculator, write down the 4 first, and then shift divide. So they should come out the C and then 0, which the answer will give you 1. And then for C1, the answer will give you 4. For C2, the answer will give you 6. And then for C3, another 4. For C4, that is 1. So nanti kita akan dapat jawapan yang sama macam tadi lah. Sama saja, cuma bezanya nombor yang depan je. Kalau tidak kita guna Pascal triangle kan, tapi kalau kata sampai kuasa 20, takkan awak nak guna Pascal sampai 20 tu. Penuh kertas A4 tu. So that is the reason why we are going to use the binomial coefficient. Okay, so done with this. Okay, let us try to expand a little bit. What is 5 factorial? So like I teach you before, 5 factorial is 5 times 4 times 3 times 2 times 1. So if you expand everything, this one is simply 120. So this is the factorial thing. How are we going to use the calculator? Kalau calculator kena guna 5 and then shift, lepas tu ada X yang kuasa negatif 1 tu. Tekan shift dulu and then X to the power of negative 1 tu. So you are going to get the factorial formula, which is 1 to 0. Okay, let us go to the last one. Okay, the first one you need to calculate what is 5C2. I'm sure you can use your calculator, but we just want to see from the formula how are we going to calculate 5C2, and then you should show that NC2 is actually n multiplied with n minus 1 over 2. Okay, so now let us use the formula for NCR. So NCR is n factorial over n minus r factorial r factorial. Okay, so this is the value of n, this is the value of r. Let us substitute into the formula. So 5 factorial over 5 minus 2 factorial over 2 factorial. Okay, so you simply substitute the n and the r. So simply substitute and then simplify them a little bit. So this is 5 factorial over 3 factorial over 2 factorial. Okay, so 5 factorial, this is 5 times 4 times 3 times 2 times 1 over 3 factorial, 3 times 2 times 1. 2 factorial times 2 times 1. And then you divide them. 1, 1, 2, 1, 3, 3, 4, 2, 2. So when you simplify them, it will become 10. 5 times 2, 10. So kita simplify sajalah sebab kita ada bahagi kan. So cancel, 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 cancel. Okay, so now let us see what happens if we have NC2. So now again we are going to use the formula over here, NCR, except now the value of R is 2. So we are going to get n factorial over n minus 2 factorial, 2 factorial. Okay, so how are we going to expand or simplify them? Okay, so we start with the highest number, which is n factorial, and then we keep on delete 1 to that number. So n factorial is simply n multiply with n minus 1 multiply with n minus 2 factorial. So it's like having 5 factorial. 5 factorial is 5 multiply with 4 multiply with 3 factorial. Sebab 3 factorial ni 3 times 2 times 1. So I can actually simplify them to become 5 times 4 times 3 factorial. Or if I want to, I can write down 5 factorial is 5 multiply with 4 factorial. So kita akan darab sampai satu nombor tu kita letak je factorial. Okay, and then you should be able to see this is n minus 2 factorial, this is n minus 2 factorial. So you should be able to cancel out those two. You will be left with n minus 1 over 2, which is proven, shown. Okay, so that's it for lecture 2. Okay, so thanks a lot for listening until 1 hour and 20 minutes. So I'll see you guys. I'll give you a break for around 10 minutes and then I'll send you the link for the Google Meet. I'll see you guys later. Thank you. Pergi minum air dulu ke apa ke. Jumpa nanti. Bye-bye. Kesian pula lama.